Matrices and data, new chapter, chapter 4. We have some vocabulary words. Matrix, it's a rectangular array of numbers enclosed in brackets. It's just a grouping. We have dimensions. Dimensions, we're going to call them M by N, M being the number of rows, N being the number of columns. So we have a rectangular array of numbers enclosed in brackets, and we have so many rows and so many columns, and they're going to be numbers, a 2 by 4, a 2 by 2, a 4 by 4, M by N. It's always going to be rows by columns. An entry, each value in the matrix is called an entry. An address, just like your house has an address, the location of an entry has an address, and we'll show you how that works. Scalar, we're multiplying a matrix by one number. It's called a scalar, multiplying each entry in the matrix by that number. More explanation. The table shows the top scores for girls in barrel racing at the 2004 National High School Rodeo Finals. The data can be presented in a table or a spreadsheet as rows and columns of numbers. You can also use a matrix to show table data. A matrix is a rectangular array of numbers enclosed in brackets. So here we have our data. I have so many rows, 2 rows, and 3 columns. We take that data and we put it in what's called a matrix with brackets. I have 2 rows, 3 columns, and we've labeled it matrix A. So we just took the data and put it in the rows and columns. Okay, the same matrix, matrix A, our dimensions. Remember, it's M by N, M being the rows, N being the columns. So this is called a 2 by 3. The dimensions are 2 rows, 3 columns, or a 2 by 3. An entry. We said that an entry, each value in a matrix is called an entry of the matrix. So as an example, this is an entry. 16.206 is an entry in that matrix. And the address for that particular entry, the address, we write a small a, and it is in row 2, column 1, A sub 2, 1. So our address is always M and then N. Let's try an example, displaying data in matrix form. Our first example is the prices for different sandwiches are presented below, right there. Display the data in matrix form. So I'm going to put a bracket and write the information. So I've written everything in the same order that you see it, and I've put it in brackets. Okay, and we're going to name it capital P. This is matrix P. What are the dimensions? We do M by N, M being a row, N being a column. There are 3 rows and 2 columns. What is entry P sub 3 2? So the 3rd row, the 2nd column, it is $5.25. What is the address of $5.95? It is the 1st row, the 2nd column. Cool? All right, you try. Use matrix M to answer the questions below. Push pause and try on your own. All right, there you go. It's a 3 by 4, 3 rows, 4 columns. The entry at M sub 3 2, is 11. And entry 0 appears at M sub 1 4 and M sub 2 3. All right, now we're going to add and subtract matrices. To add or subtract 2 matrices, add or subtract the corresponding entries. So you see I've got a 1 by 2. So I'm adding the first location with the first location, and I'm getting the new one. So 1 plus 5 equals 6, 2 plus 10 equals 12. You always just add the corresponding entries. They have to be the same dimensions. Okay, here I have a 2 by 2 and a 2 by 2. I can add those together. I have a 3 by 1 and a 3 by 1. I can add those together. But I cannot add a 1 by 2 and a 2 by 1. It has to be the exact same dimensions. And I cannot add a 1 by 2 and a 1 by 3. They have to be exactly the same. Let's try one. Add or subtract if possible. And you're always going to get a list of matrices at the top of a page and then a few problems to deal with them. So W plus Y. W is a 2 by 2. Y is a 2 by 2. So I can just add them together. I'm going to rewrite them. Plus. And then I just take each entry and I add them together. 3 plus 1 is 4. Negative 2 plus 4 is 2. 1 plus negative 2 is negative 1. And I'm putting them in the exact same location or address. 0 plus 3 is 3. And I have my new answer. Try another one. X minus Z. X is a 2 by 3, rows and columns. Z is a 2 by 3. So let's subtract them. I'm going to rewrite them first. I'm going to subtract each address, each entry. So 4 minus 2 is 2. 7 minus a negative 2 is 9. 2 minus 3 is negative 1. 5 minus 1 is 4. 1 minus 0 is 1. Negative 1 minus 4 is negative 5. And I have my new matrix. Okay, let's try X plus Y. X is a 2 by 3, Y is a 2 by 2. They are not the same dimensions, so it is not possible. You don't have to do anything. Okay, you try this one. Add or subtract if possible. Push pause, please. There you go. Let's try another one. B minus A and B minus D. You try. Okay, B minus A is not possible. D minus B is. But please remember, when you're subtracting numbers, order does matter. And watch your negatives. Okay, let's move on to examples 3 and 4. You can multiply a matrix by a number called a scalar. To find the product of a scalar and a matrix, or the scalar product, multiply each entry by the scalar. So, our first example says evaluate 3p. Our scalar is what? 3. So now I'm going to take 3p, 3 times everything in that matrix. I take 3 times 3, 9, negative 6, 3, 0, 6, and negative 3. Okay, that is my scalar product. I multiplied 3 by everything in that matrix. That means we can do a lot of fun math with scalar products and matrices. Evaluate 3r minus p. If you look, this is a rows by columns, rows by columns. I take 3 times r minus p. First, let's see what 3r is. 3 times this matrix. 3, 12, negative 2, nope. Negative 6, 9, 0, and 12. So 3r, should have written that somewhere else the first time, minus p. I'm going to do the subtraction. 3 minus 3 is 0. 12 minus negative 2 is 14. Negative 6 minus 1, negative 7. 9 minus 0 is 9. 0 minus 2 is negative 2. 12 minus a negative 1 is 13. There is your answer. Cool? All right, you try. Evaluate 2a minus 3c. Please push pause and try on your own. All right, I think I added and subtracted correctly. That is what I got for an answer. Okay, you can also use a scalar product in real world situations to find things like increase in price, discount, sales, stuff like that. So if we use a scalar product to find the prices, if a 10% discount is applied to the prices above, it's pretty simple just to set up a matrix with all the prices. Give me a second. So if I wanted to do 10% discount, I would take my original price and subtract 10% from that price. I would do the scalar product, set up a problem like this. Make sense? So let's figure out 1% of each one of those. I'm going to push pause and do the multiplication there, so just hold up for a second. Sorry, I didn't think you guys needed to watch me do addition and subtraction. So what I did here was I set up my original matrix and then a scalar product, 0.1 times that original matrix. That means I'm discounting 10%. So if I take 10% of the price and subtract it from the original amount, which I'm doing right here, original amount minus 10%, I get what my discounted prices will be. Why don't you guys try this one? Use a scalar product to find the prices if a 20% discount is applied to the ticket service prices. So I'm taking this information, multiplying it by 0.2, and subtracting from the original price. Please try on your own.
From California who have come here, and they have changed the complexion of this state. It's now a very purple state. A third Democratic, a third Republican, in this county where I am, a third independent. We're here in Arapahoe, which is south of Denver, one of the swingiest of the swing counties. You can see behind me they're counting ballots. They're counting ballots that have already been mailed in. That's the numbers we're working on now. This is a big mail-in early, vote early state here in Arapahoe County. About 68% people mailed in before voting even started today. Now, this is a state that was concerned about voting problems, but it didn't turn out that way. Because so many people voted early, the polling places really were able to handle people who showed up. One area where they had a 90-minute, 2-hour wait, and they said to people, look, if you just change precincts, you can go next door and you can vote in 5 minutes. That said, now this state is really beginning to count the votes that were cast today, about a third of the votes. And it could be a while here in Arapahoe County where they are counting the votes that have come in early. They are prepared to work late into the night. Scott, I am telling you, bad news for all of us. They have another shift ready to come on duty at 11 p.m. and count the night away.
Barry, thank you very much. You know, Bob, I think back on that very first presidential debate. It was in Colorado. That was the debate that Mitt Romney won. The president had done poorly, and Mitt Romney had convinced a lot of people in this country to take a second look, and now they're battling it out for Colorado.
I think that was one of the shifts we saw here. I think we saw a shift toward Barack Obama after the Democratic convention. Then after that Republican convention, that sort of stopped for a while, and we saw it starting to shift toward Mitt Romney. The question is was it still going up until Election Day, or did it peak a day or two before? We haven't had much good news for Governor Romney in the last hour, but here is one little bit of good news on Colorado. There are 38% of the vote out there are independents, and according to our exit polling, Governor Romney is leading among independents by 7 points now.
Nor the unemployment rate in Colorado is 8%, just slightly above the national average.
And Colorado is a state that has changed a lot, which is why it went